Did you try the video? Did you go through?
Yes.
Although it's a silent video, it
Yes.
has many actions which
Yes.
you need to understand. The what do you call form work, design criteria, uh, erection, right? Form of erection is the installation, and then all types of activities involved in formwork has been explained in 30 minutes video, I suppose. You can go through and understand, and some other videos also with coming with audio. Please go through and learn, right? These are all important for your further learning. So what are the things we continued with the deep foundation, formwork types we learn, and construction of formwork processes. Mute your microphone, please. Advantages, disadvantages of formwork. Just we started with advantages and disadvantages. Lastly, quizzes. Okay, and then formwork to recall. These are the different types of formworks. Formwork. What is formwork? Is helping you to form your building elements. It may be slab. It may be a slab like this. Okay, slab like this. It may be a beam. It may be a column. It may be a slab like this. It may be a flooring later on. It may be a staircase, right? It's a temporary structure used for forming or preparing your elements, building elements in situ at the site. Right? These are the component parts of a formwork. You can see here the wood and a composite material, wood and steel frameworks are used to form your formwork, and different component parts we studied last class. I will also go through again whenever there is a change in the material. Okay, columns also we have attended last class, and the shear wall, and this is the result of deep foundation. Okay, result of last quiz. Very good, you're given your real names: Tanzi Hao, Kujun, Ali Mohammed, Miatmin, until Yamin, Yalamzube, 10 champions, all getting 100, 80% above. Very good. Give them a big hand. 10 champions of deep foundation. All of us clap. There is a good effect in clapping. Medical effect, medical reactions, and medical changes is happening in your body when you clap. Okay, good. Let's move on. I should see all 114 here, champions of every class. Try your best. Today's class, design requirement of formwork. We'll go into design requirement, construction requirement. All right. Design loads. What? Microphone off, microphone. Fun later. Design loads on formwork, materials of formwork, right? Is a advantage, disadvantage from work and quiz, right? We will have all these things one by one, right? Formwork requirement. Start with design. It is also having and the designs, right? It can, you can say design or construction, both goes together. It follows the design of a beam or column, so there is no exclusive design as such, but there are some kind of loads that you need to undertake, consider during your formwork preparation, right? That we will see later. This is about design requirements. Okay, how can you say, or when can you say a formwork is a good formwork, the best formwork, reliable, cost effective, right? There are so many factors involved in, and as an engineer you have to know the requirements. Let's say one by one. Rigid. Your formwork should be rigid, strong enough to take over the load coming in, right? Not many loads. There are three types of loads mainly: the concrete load, which it is going to hold, stay there until it's set, right? There are a number of days given there, right? And it is not only concrete, slurry material, water is poured during curing, so state of temperature, state of the slurry is also changing. So at all temperatures, at all times throughout the curing period and during construction, it should be rigid enough. You should bear the weight of the dead load, live load, and also the other types of load that is coming over during its construction. So it should be rigid to prevent building or movement from pouring wet concrete. So during pouring, it should not move, slide, displaced. So it should be strong enough. Choose the material, choose the size such a way that it will stay strong, hold until it is done, and even after the period of, until it is stripped off, right? After curing, it should be stripped off. And then tight joints. You should have tight joints. it's not a one panel which is using formwork. It's a continuous panel or a fabricated one, modular, or otherwise a network, or what you call disjointed, just so that they are jointed by heel or by resins. Plywood, if you take, all by resins, you're connected by resins. So there are different panels which are put together to form your formwork for concreting a slab or concreting a beam or column. So the joints should be taken care. Your formwork should have tight joints, otherwise it will be leaking. When you pour the wet concrete, it will start leaking if you have joints. So take care of the joints. Choose the material such a way that it will have less joints or preventing. Even joints can be prevented. If at all if found, it can be prevented later on, fixed later on. Shrinkage and swelling should be minimum, right? And the material shrinkage and material should not shrink or swell or bend or thaw or freeze during its construction or all through the period of its curing. So avoid the material, choose the material such a way that it has less shrinking, less failure of the material property. Formwork requirement further, you should have a simplicity, right? Because it's a temporary structure, it's not a permanent structure. Don't go for a complicated, costly, right? Go for a cost-effective, stronger materials and sizes. Sizes anyway, it's going to follow the size of the beam and column, but adapt the exact size. Adapt simple materials like easy erection, dismantling, right? Easy for handling, easy for assembling and dismantling. Bond breaking agents such as grease is typically applied to the form faces to prevent concrete striking. So it should be easily handleable. Use materials, adhesives such a way that, lubricants such a way that it can be easily removed, easily handled during installation and during dismantling. Standardized sizes. Now you follow the standardized sizes. Unstandardized size, non-standardized sizes also can be followed, right? At corners, right? At some corners or some irregular shape or different shapes, at times of the edges where you cannot close it, you can use it. But mostly use a standardized size like 6 by 6 means 6 is all 6 by 6. At the end, you may encounter a non-standardized size of a panel, so you can still use it. As far as possible, you have to use all standardized sizes all through the formwork. Form finish, to achieve desired texture and appearance of finished product. Yeah, form finish, the formwork should have the surface such that it is smoother, so that when it is stripped off after curing, it will be easily taken off. It won't take the material of the concrete or giving uneven shape, uneven surface on the concrete. When it's stripped off, the surface should be smoother, evenly constructed. The size should not be varying. So choose such a material which has smooth surface like plywood, steel also can achieve some, and then PVC and so on. Okay, economy, simple, affordable, easily handled and standardized. Price is matter, because again I come back to this temporary structure. Formworks of the temporary structure, so should be affordable, cheaper, reusable. I think there's a separate heading, or I can put it here itself. When you say cheaper, must be reusable. You can use multiple number of times, so you are saving cost. Economy is saved, right? Your economy is under budget, not overshooting. Easily handled, right? Easily handled and standardized. So you can remember and install at points, I mean wherever you need, and you can supply wherever it is necessary. So that's important, to have simple, affordable and handleable economic materials to be used. In a nutshell, your formwork should be rigid, tight joints, right? Tight joints are not leaking, joints are stable at all the times during construction of concrete or until it is stripped off. The panels are stripped off, removed from the concrete formwork. And then shrinkages, swelling, failure should be minimum. Simplicity, right? Simplicity. And in this one, tight joints also having another factor, minimize the joints. By that you can have tight joints, right? Minimize the joints. Choose material which can go for a long panel, and not small panels, right? Longer, broader panels. You will see some videos also, interesting videos, today's technology, how effectively they are using this formwork, how successful they are bringing these innovative materials in construction. By that, these types of problems are rectified, and so their formworks are the best. Shrinkages should be minimum. Simplicity, standardized sizes, prefer only standardized sizes. Form finish surface should be smaller, and then economy, cheaper and reusable, must be used for many number of times. Then you can say your formwork is the good one. It is following, it is complying with the requirement of a good formwork. In addition to that, there are general formwork requirements. Should be strong enough to support the load of wet concrete, which is generally considered to be approximately 24,000 kilogram per meter cube. What is this number? Anybody?
Density.
Very good. So compare the density of the material that you are using, right? Later, when we go to materials, you have to answer me, which is denser, which is lighter, what effect, why it is so. All these properties we will discuss. Now, in first place, density of the material should be borne, supported by these formwork, right? So to the extent of 24 in kilonewtons, how much? 2400 kilogram per meter cube. Just leave it, we don't convert it because it's only the mass, right? Okay. Should be strong enough to support the load of wet concrete. That's important. Okay, by the way, what is the strength of concrete? This is density. Strength of concrete. Now any grade you can choose. If I say C8, C10, C10 means what is the strength of concrete? The grade C10, C40, C20, C30. Okay, there are different grades for concreting. Okay, if I say C10, it will have 8 to 10, it can bear 8 to 10 kilonewton load. If I say C40, quick value from the codes. You can follow any type of code, but mostly in Malaysia and most of the countries they follow borrowed codes from British. America they're having their own, Australia they're having their own, India they're having their own. So it depends on the nation. They may follow their own code, or it may be the modified one, which is taken from these British standards. Okay. Okay, what's that? Concrete. If I say C40, it will bear 40 Newton, 40 kilonewton, 40 kilonewton load it can bear. So these are the way we classify the strength in terms of weight. Okay, the weight it can bear, weight it can take in. Okay, if I say C40, 40 kilonewton weight the concrete can bear. So there are different types of weights coming over and has to be borne by, supported by the column or beam or whatever the elements you are constructing. So bear in mind. Formworks also acts as a temporary structure that supports, oh it's here, its own weight, freshly placed concrete, right? The freshly placed concrete will be heavier, denser, and then construction live load, material. So these are things, its own concrete, its own weight, formwork's own weight, the concrete which is placed inside, and also the live load, the people who are moving on the formwork. If it is a roof, it is even vulnerable, right? All people will be moving and pouring concrete. Above all these formworks are necessary whenever there is a element of the building which is constructed more than 1.5 meter above. Okay, if it is less, no need of formwork. You can go by some other temporary support, or even you can just like if it is a foundation, the pit will support, right? The pit that you are digging out will be supporting the concrete or any type of foundation. It may be brickwork or concrete or stonework. But if it is higher than 1.5, you must go for formwork. Using formwork, you can form or you can build your structural elements. So need to consider these types of loads. Any questions so far?
No, please.
How many of you joined? 2 times. In the next week, honestly, I have to check twice, in person and online. 104, good attendance. What happened to 10 people? The 10 is always there, not going down. The number is not going down. Okay, you can see the slide.
Yes, miss.
Thank you. It must have grout tight joints. Generally, start from joints. Grout tight means you can do, if at all any gaps are there, you do some grouting. We'll see here. Grout leakage can cause honeycombing of the surface or produce fins which have to be removed. The making good of defective concrete surface is both time consuming and costly. Grout leakage can be prevented by using sheet materials and sealing the joints with flexible foamed polyurethane strip or by using a special self-adhesive tapes. So common type of problems, these are common types of problems since we are reusing the material, maybe wood. This is most common. The grout type joints are most common in wood, where honeycombs are very common. And then what the stoneware pipes, these are all very common type of problems at the joints. So you can overcome by proper sealing. Before using, you check by proper sealing the joints using these types of polyurethane strip or grouting method. You can do the grouting method by using slurry. You can fill up the holes, cure it, harden it, then you start using it. We'll see with the pictures on the next slide. Honeycombing like this. I think it's a concrete and pre-stressed concrete type. You see here the formwork has been worn out, material itself removed. The honeycombing or a type of joint failure may be like this. Material itself removed. It's like a small parcel of the material gone off. At the end, it will spoil the structure which is going to be built. So if you build a structure, all the concrete will be leaked through these holes, isn't it? So you need to avoid this or fix it first and then use it. You can use this polyurethane strip or by using special type of adhesive tapes. Tapes depending on the material, which adhesive can stick to surface. You can use it accordingly to prevent this honeycombing. It must not be able to deflect under load. Basic requirements, and number one is the joints, because you're using panel by panel. It's not one panel which holds the entire slab. Second common mistake, common problem will be deflect, because you're going higher and higher, isn't it? Going higher and higher, and temporary structure, you're not really digging a foundation to hold these structures, right? It's hardly drilled, right? Just drilled inside, or using some plates and screwing. They will be, or welding, small welding. It will be done, plate to the ground, supported to the ground. So it is all by self-weight. It's standing by its own self-weight. So you need to take care of the deflection. Under load, which would include the loading of wet concrete, self-weight, any superimposed loads such as operatives and borrow runs over the formwork. So the concreting, if it is manual, there people are standing, right, equally spaced, and they are standing at intervals. They are throwing the pans for the concreting, and this type of load, moving load, concentrated load, also there. So your formwork should be bearing with both type of moving and concentrated loads during its construction. In all conditions, the formworks especially which is at height, slab, right, slab or a beam at height should be taken care for its deflection. So this deflection can be overcome by proper spacing, proper fixing, especially joint to joint. It should be connected center to center, right, center to center. These things are also very important to take care. Once the formwork is done, as an engineer, you go to the site, you check what is the spacing, what is the, whether it's the center to center is followed, right, and what is the, how much packing is done at the bottom for holding the pole. All these things you have to check. Make sure you can even check it and check, cross check whether it is viable, it is about to fail, and then confirm it, approve it, before you go for concreting. With that, you are able to overcome these troubles of deflection, displacement, right? It's a little hazardous, right? The whole work will be spoiled. All not only work, time, people, right? Hazardous at the site. When people are subject working at site, they may get affected if there is any sway or if there is any displacement of the poles. So care should be taken to avoid all this time. It must be accurately set out. Yeah, that's why the center to center spacing should be evenly done. Sizing of the poles are there, we will see later on. You should know which size you have to adapt in the middle, at the corner, and at the uh, typical points like where the beam is coming, beam load, right? Beam, if I say beam load, it has already taken the slab load, the slab already taken the loads above, right? So you know how the transfer of the load. In earlier class, like, I don't remember where it is, but 2-3 classes before we studied what is the mode of transfer of load from superstructure to the foundation. In that, you should know where it is a worst condition of loading. Accordingly, you need to follow and set out the spacing and the support. Concrete being a very soft when placed, it will take up the shape of the formwork, which must be therefore the correct shape, size. Yeah, that's what I said. All the beams, columns are designed before, and the formwork will follow exactly the size of the beam, size of the column, size of the slab. So you have to properly design it. No gap should be there. You can grease it, hardly you can grease it to form a smooth surface between the wall of the formwork, inside wall of the formwork and the concrete surface, so that you can easily remove later on. Other than that, it should exactly follow the size of the members. This we have seen already. This video you already seen. I don't play again. Do you have any question in the video? Last class, end of last class, I posted a video. Do you have any question in the video?
No,
Did you
miss.
did you listen to the video, all of you? If not, please check once again. It has given A to Z of form work, right? And until the concreting, and it's a good video. That's why I brought it. And there are some other videos with regard to the formwork installation, tools used for formwork, right? Although you are not going to do it, you should know how it is being built, right? What are the tools, hardware is used, how to use the hardware, what are the names of the hardware. There's another video I posted. Although it is not under our scope, you know, for more understanding, better understanding, you please go to the slides. I mean the selected videos I have posted at the end of the slide. Okay, I posted a few slides and few videos today. Please go through while reading, while preparing for your assessments. Okay, sufficiently rigid to prevent undue deflection during the placing of the concrete, starting from placing of the concrete and all through the period of curing. What is the period of curing? I keep saying it should be stable during period of curing. What may be the period of curing?
2 weeks.
For all, for all concrete. Okay, let it be 24 hour, 24 sorry, 2 weeks, 14 days, right? He's saying 14 days for curing. Yes, for slab, is it same?
A month.
A month. It depends, but nowadays they are having quick setting cement with a quick setting cement admixtures. It can be reduced, but generally speaking, slabs will go for 1 month, and columns, beams, all the other concreting work will be there for 14 days curing. And farm work slightly following this, but I will tell you what's the sequence of removing the form work. I will explain after this. So there is a sequence in line with the concreting. Why do we do curing? Anybody? Why curing is necessary in concreting? It's a basic question. Importance of curing. I don't go surfing and then tell me. Answer, please. What's the purpose of curing?
To
achieve the
prevent
strength.
the concrete from absorbing extra water.
No. Okay, I will answer.
To
To
become
achieve the
harder.
strength. To achieve the strength. required strength of the grade. Okay, just now I said the concrete will be for different grades. Which grade you are following, M or C or whatever the grade you are following, it has its own strength. Okay, to achieve its required strength of the required, I mean the given grade, the curing is important. Concrete, after pouring, it is there in the formwork for a certain duration of time to get hardened, eventually attain the strength of concrete. If I say it will bear 20 tons, 20 kilonewton, it should bear 40 kilonewton, it should bear. Only if proper curing is done. And there are many other advantages you will study later on when you go for RCC. What are the advantages? It will explain to remove all the air voids, right? You have to pour water to remove all the air voids, to fill up or to know what are the pores, so that you can later fill up with cement slurry to completely pack it and have a solid structure which can take load. Many other advantages are there, right? But the main and foremost advantage is to achieve the strength of the concrete, right? Only if the concrete is strong enough, you can bear the load, right? To achieve the strength of the concrete, it should be cured. No curing, no strength. It's like a loose material, soil material. It won't take any load, right? So the achieving strength, you have to wait for some duration of time, depending on the grades, depending on the proportions of the ingredients. Sufficient strength to carry the working load and the weight or pressure of the wet concrete, and to withstand incidental loading and vibrations of the concrete. So here, when we talk about the formwork, it is a temporary structure. It's not going to take up any load in future, right? It is not there. Formwork doesn't do any of the load taking during its service period, right? The formwork is there temporarily only during construction. It will take only during construction. Once constructed, it's all removed. So you need to design the formwork such a way that it will bear the loads during construction, the working load and the weight or the pressure which is coming due to the wet concrete, due to the people standing there pouring the concrete, moving, and later on to curing, during curing, until the end of the period of curing. It should withstand all type of loading. Vibrations, yeah. After pouring concrete, they do the consolidation, right? Some of the videos you would have seen before, they do the consolidation using machines. So the vibrators should also not disturb the formwork. During vibration, if the shape of the formwork is changed, like square column, for example, you're doing a square column. During vibration, it changed to slightly changing in a diagonal way. Your size is lost, right? Your design is lost. The predefined designed load will not be achieved. The column will not withstand with the load according to its design. So you have to properly design a formwork, firm the formwork, or strengthen the formwork such a way it will not deflect, it will not change due to the moving loads, dynamic loads over the structure. Set to line and level within the specified tolerance and include any camber which may be required. Okay, so you have to before you start the concreting, you should level it. You should check, for example, if it is a square, you check the diagonal. Okay, if you check the diagonal, you can adjust the square already, right? So diagonals will be helpful to check. There are nice videos wherein it will show how the diagonals, how the formwork is assembled, formwork is prepared. So always they put the panels together and then they check by the size. Number one is the size. Then they check the diagonal. Mathematically, you can calculate the diagonal, right? And then adjust according to the diagonal using the laser level or plumb bob to adjust its height and the size cross section. So that you can avoid all these types of bending, non-collimation. Everything can be overcome. Joints should be sufficiently tight. We keep saying joints should be tight, leak proof, to prevent loss of mortar from the concrete. It's not only loss of mortar, uh, shape might be changed. You don't get the smooth surface, right? Size of panels or units should be should permit easy handling. Okay, general requirements should be easily handleable. Panel should be of size, cannot be very long, which the crane itself cannot carry. The crane pad itself cannot carry or over tilted or overturned, right? So design the panel, use the material such a way that it is easily handleable, and then position at the former place. Design should permit an orderly and simple method of erection and striking. Yes, uh, your design of your form of design, right? The size, the shape that you have designed should be easily handleable, right? Although you're going to pour inside the column should be of size which is handleable, which can be moved from the place where the centering and the centering work is going on to the place where the insulation where it is supposed to be constructed. So overall the material, the weight of the material and the quality of the material should be chosen such a way that it can avoid leaks, it can be tightly put together the panels and then easily handled. So for small buildings and small residential buildings, single story building or just a shop lot, sometimes the manually it is handled manually, no cranes are employed. So manual handling should be made easier, quicker, if it is less weight and of reasonable size, not a very broad, uneven size, and so on. Design should permit, it will also help in erection and striking or positioning the formwork at the place you need to pour the concrete. Arrangement of the panels should be such way that they are not trapped, okay, during striking, and it should be possible to strike side from beams without disturbing the soft fit formwork. This is saying about the removal of the formwork after the concrete is hardened or after the concrete is set. When you remove, you should not take away the material, you strike and remove it, right? If because it is stuck together, the bonding is very hard. You need to give a blow so that it will throw off from, I mean, it will remove from, get removed or stripped off from the surface of the concrete which you built already, which you hardened already, right? So for removing safely the formwork, and also it won't damage the formwork as well as the element that you constructed. So you have to avoid not trapped. You should not, care should be taken. The materials are not trapped away, removed away from the formwork. You have to achieve a smooth surface, clean surface at the end of the construction. Okay, loads. Just now we finish what are the general requirement and mostly saying about joints. The failure should be avoided, and then the surface should be small, affordable, easily handleable, and so on. Okay. Coming to design load, what are the design loads that you will be designing in designing the formwork, in assembling the formwork or preparing your formwork? Herein I have mentioned the American Code, American Concrete Institute, ACI 347 guides formwork for concrete stated as these are the loads. Okay, according to American codes, these are the loads. It depends on the company you're joining, or if you're doing project, you can choose any one code, right? Either Malaysian code or British code, American code, to follow all through your design. Here it is mentioned about the American code. Accordingly, in the code book, only 3 types of loading is given for designing your formwork: dead load, live load or live load. You can pronounce it in any way. European and Americans pronounce it will be bit different. Lateral load on formwork. These are the 3 types of loads which you need to design during your formwork design, construction of formwork. Actual weight of the form and fresh concrete. So dead weight is weight of the concrete and the self weight of the formwork. We can say self weight of the formwork, right? Plus fresh concrete. According to this, don't ask me why fresh concrete is coming in here, because it's also the element, right? So they put it as a dead weight. It is not moving. Live means is something like moving or changing. Here self weight is its own weight, moment, kind of power to withstand, right? Power to withstand. So when you talk about the power to withstand structure as a whole, you need to consider both form and the concrete, the shutter and the concrete. Form or shutters, we call these as shutters, and the form is developed using shutters to pour your concrete, to prepare your concrete. So the form or the shutters and the fresh concrete put together is called dead load. Live load, weight of the workers who is coming and pouring the concrete, carrying the concrete, machinery is used, equipment, material storage. Sometimes the materials are stored on the top and they may be mixing concrete beside to pour into the formwork. So all these types of moving loads or changing loads, in other words changing loads. The material will be there, they're mixing concrete, once mixing and poured, the place is clean, right? So changing loads, live loads, lateral load on formwork. Wet concrete is like water, slurry type, exerts a lateral pressure which increases with the depth of form. Okay, uh, because it's mixing with water, water has shearing strength, right? Water will tend to shear along the surface, along the, it will tend to shear, right? So you need to avoid these types of pressure that is built up as you keep on constructing the column or slab, right? You need to take care of the shearing strength or shear failure of the concrete due to water mixed in or due to the slurry formation of the concrete. Okay, that is called lateral load. That will lead to lateral load or side pressures. It will yield, it will exert a side pressure onto the earthwork, sorry, onto the formwork, which may affect the formwork shape or the dimension of the formwork. So care should be taken in such a way that the built-up pressure due to water on the sides should be avoided, right? Or time, maybe by controlling the time, by controlling the proportion of the concrete, you can avoid this problem. Okay, so this type of loading is also inevitable, we cannot avoid. Okay, because it's a slurry form. Until it's get hardened, there will be a chance of loading. So you need to include, then you can take percentage of this loading, that's all. You know, you cannot exactly calculate, you can take percentage of this loading for lateral load on formwork, which is due to shearing load, shear load due to the water in the concrete mixture. And it is as the head of water and the slurry is growing, the load, the pressure onto the formwork is also increasing. So care should be taken to include this type of loading as well. What is he doing? Oh, this is already there. So formwork, whenever you use the formwork, greasing is important. Why? Greasing, lubricant is applied to the surface of the formwork before pouring concrete. Why?
To
Excuse me.
prevent the concrete from being stripped off.
To prevent, no, easy removal of the formwork after the concrete gets hardened. Okay, the grease is applied so that, and these things worker on the project greases the joints between the bolts to ensure they are grout tight. Oh, here he's fixing the joints. He's fixing the joints to avoid any holes. Just now we saw the holes, right? Grout holes, and there's a honeycomb type or any joints having some small holes, right? He's greasing the holes, filling the holes to avoid any grout type, to ensure that the grout, just forget about grout type. If there's any holes, you need to be filled before the concrete is poured so that you have an even surface. All right, he's doing fixing honeycombs, fixing holes in the formwork. Okay, but generally all the formworks are greased inside. Okay, before pouring concrete, it has to be greased inside so that when it is done, formwork is done, when the concrete is done, when it is stripped off, it can be easily done. It can come out very easily. Okay, come on. Materials, very important topic. We are going into materials. I also have some interesting videos you can see later. One moment. Okay, you're getting time. Materials. Generally, we can classify into wood, metal, and plastic. All right, wood, metal, and plastic. No other material. Do you think you can use any other material quickly? Any answer? Why we have three and we can have a many number? Do you have any suggestion in this? According to the tags, according to my own survey, these are the things I put in recently. I found there are only three types. Do you think there are any more types of formwork? Answer me. Am I going fast? Am I talking fast? You please tell me if there is any words are not clear. Okay, nowadays these videos are coming with transcripts. You can also do transcript, but I have to be pronouncing correctly. Some words may be misspelled. Careful. I don't know for which accent it is doing the transcript. If you are fortunate, you will get the exact words. These videos you can have transcripts. Okay. 110. 4 people missing. Right, where is the slide? I was asking about the material. You can see the slide?
Yes.
Oh, thank God.
Yes.
Do you find any material? You had a material subject, right? So people are, yeah, construction materials. Yes, you have. Based on your material knowledge, please suggest to me, is there any other material which can pave way for your new research in construction if you're doing in your master's or PhD? Do you find any other material than this? Wood, metal, plastic? For formwork? Okay, keep thinking. Let's go through this. Wood can be timber, plywood, or any other type. Because these are all the bamboo also can, but see that the cost and then strength. Okay. These are the affordable, cheap, good material, reasonably good material for doing your formwork. If you take metal, it may be steel, aluminum mostly. So far, steel and aluminum, affordable, cheap, good strength material. When you compare across the cost, timber, plywood, steel. So which is high? Cost. You see the dollars there, coins there. Which is high?
Steel.
Timber, plywood, steel. Which is costly, expensive?
Steel.
Steel. Metals are
Steel.
expensive. Yeah, metals are expensive. You know your budget, right? If you're an engineer, if you're a planner for your, manager, project manager for your project in future, choose among these materials, right? If cost is the matter, you go for this. Cost is not a matter, but you want a very good work done. And there are advantages and disadvantages between all these three materials. We will see one by one. But in terms of costs, if there is a cost constraint, you go for this. No cost constraint, go for this. Okay. And relatively less is this one, plywood. Timber, any type of wood, and timber, and then this is plywood, and this is steel. Plastic. Okay, there are a number of materials nowadays. I will show one of the videos at the end of this material section. You really appreciate how advanced we are in using materials. Plastic, glass reinforced plastic formwork. Glass reinforced plastic formwork. It's not steel reinforced. They put the glass fibers inside to form their plastic formwork to attain their strength. What is going on? Somebody's talking. Okay, see the picture, all plastic. Not this one, here you see here only. These are all the support. So this is the plastic glass reinforced. You can see the small lights. These are the reinforcement inside. These are the reinforcement inside. Did I take the laser? These are the reinforcement inside, glass reinforcement inside. Plastic panels are used as a scaffolding or formwork. For it may be used for walls, constructing walls. Okay, let's see one by one. Timber formwork. Timber formwork basic standard qualities are All of you know it's very cheap, affordable, good quality, easily available, transportable, handleable. Always remember those good requirements of a form work. The summary, quickly I go read for you, so that when you go through these slides, you remember these points. When you achieve these things, you can suggest that particular material. Should be rigid, tight joints, right? No gaps, or joints should be rigid, and then avoid any failure of shrinkage, swelling, bending, sliding, swaying. Simple, mean easy to handle, and then standardized size, mostly available in standardized size, and then form finish should be smooth surface, and reusable. Economy means reusable, cheap material, at the same time reusable. Keep all these 7 points in your mind when you discuss about materials. Reasonable price, first one, affordable, economy, available, easily available. You can grow trees and you can do it. What? Hmm? Somebody should not be so soft. Okay, timber should be hard enough, and you choose a timber such a way that it's hard enough. Maybe balsa is very expensive, but you can go for bamboo wood, relatively good, but you don't go for very soft wood, which will not withstand with the load coming in during construction itself. Should be easily worked by hand or machine and nailed easily. That's important. It should be workable, because you need to do the centering, right? When you do the centering, you put the panels together, you cross with the brackets or the screws, nails, all the tools will be, tying arrangements will be done. So it should be workable at the site. Wood is very easy, you can nail it easily, right? Should be stiff to avoid deflection, right? At the same time, stiff enough to withstand deflection or mainly wind, right? You construct, see like this, it is standing on open air, it should withstand the wind, it should withstand the wind, heavy wind. Sometimes there will be a windy storm, I mean this it will be a hurricane, trough, whatever, uh, different climate changes, right? It should withstand until it is finished. And then should be stable when exposed to sun or climate changes, so heavy downpour, sometimes sunny, right? Because it is sunny, you should not be broken, brittle, right? And then should reduce defects, right? Defects like due to heat, it will get, I will show the defects in pictures later. It may swell, more moisture, it will get swollen, right? More temperature, it will get even brittle or broken. Not suitable for green timber. Okay, bear in mind, you have
Miss,
cannot use the,
what is green
yes,
timber?
what what
What is green timber?
the color of the timber.
Oh, okay.
uh, if you cut it, means that raw and then got from the plantations directly, green timber. It should be processed. Timber should be processed before you make some. Say most of the companies, they do the formwork, they construct the formwork at the site. Okay, so the wood should be processed properly before you start doing your panels, preparing your panels at the site. So you cannot be using the raw plantations, unprocessed wood for your construction, because it is not ready to be built as a formwork, cannot bear any loading. Moisture content not less than 20 percentage. Yeah, yeah. The green timber, normally the green timber which is raw wood which is not processed, can absorb more water, end up with swelling, bending, easily bend, easily warped, right? All these problems will be there. So you choose the timber, choose the wood which is processed, which can bear with some water. It is not only moisture of the environment, it is also moisture of the concrete which is poured, right? You should not absorb everything, right? Should not very dry in such a way that it absorbs the concrete water uh, more, right? So these are the issues related to timber. It can absorb moisture from the concrete. It can spoil, tend to lose the concrete strength. So care should be taken to avoid these problems by properly choosing the timber. Here some of the formworks is shown. For the columns, it's already slab is already built, and this is the formwork for the columns. You can see the clear picture here. See they use the timber for making their columns, right? Maybe a high section or H section. They use the formwork, and then it is all tied, right? These are all the sideways, the support at the sideways, clamped to the concrete surface, and this is showing the wall. These are all the scaffold, the formwork used for construction of the wall. Maybe 10 centimeter wall or 15 centimeter wall. You see the size, very small size. Okay, and this one column, this running through is a column, wall, and this may be the column N column. Together, they are building together. This is the one of the skyscraper. Have you ever seen this type of structure anywhere? You recall which structure is it? It's in Singapore. What garden is it? Near the airport they have a garden, right? I've forgotten the name. Bayview, right? Bayview Garden in Singapore. This is during construction. The photos taken during construction. See here how many formworks are built, right? How many formworks to support this slab. This is the construction of the slab. Okay, construction of the slab going on. This is finished slab. This is the finished extended and the sideway walkway, and here it's extended. This is being built. The slab is being built here, and these are the poles which is supporting with the bracings and all the fixings. You see here the formwork is arranged for building the slab. Continuing this one, see here the height. We cannot see the picture clearly, but understand at what height it is being built, right? Height is a matter. This formwork should withstand this height and the sway due to the deflection due to wind for this whole exposed area, especially the end formworks are subject to more wind, right? So care should be taken. The end formworks are supporting for the avoiding. Care should be taken to avoid deflection due to this end formworks. And then they see the height, so high. About how many heights roughly it may be? About 70 meters, right? 70 meters and so on. About 100 meters high. So imagine, can you imagine the load that is coming in, the load that is to be borne by these scaffoldings and formworks? Foundation formwork. You see a small one, a portico in front of the house, a veranda type. A small veranda is built using the concrete slab. The concrete slab is built here using this side form. These are the side formworks, and these stackers. This is stacking the supporting the side formwork, and this is the reinforcement, right? Reinforcement. They do one by one. I think one slab is done. They put the another slab over. So they are doing this concreting using this formwork and the supporters. And here you are seeing the staircase. Okay, there is a staircase arrangement with steps. Even the steps are constructed using the formwork. Okay, the steps are constructed using the formwork. Later the concrete will be poured to build its slab first, and then they do the steps. I've shown a video, very interesting one. It will show step by step how each elements are constructed or formed. I'm talking about the formwork. How the formwork is erected and formed before concreting, and then the concrete is poured onto the formwork to build your own elements like staircase, column, beam, whatever the structure required. Advantages of timber work. Quickly we go through the advantages so that you can bring out the disadvantages later. It has both advantages and disadvantages. Depending on the site, you can choose the material for your construction. Easily available, easily handling because of its weight. So weight compared to steel, it is easily handleable. Weight is relatively less. Easy to disassemble, right? Assemble and disassembling is easier because of lightweight. Not lightweight, reasonably. Lighter than steel. Damaged part can be replaced with the new ones. You just patch up with the wood pieces. You can easily nail it because it can be easily nailed, easily. You can use a bracket, you can use the ties very conveniently, easily driven, unlike steel. Very flexible, right? You can add or remove materials very easily. More economic, easily available material, so you can the price is cheaper. Easy to handle and formed into required shapes. It's a wood by smoothing by there are techniques. I forgot the names now. They say you have to use the what oxa, right? You have to use the oxa, proper oxa to smooth it, to surface it, bring out the required form, required shape, required size. All can be achieved easily by using the tools at the side. Because if it is steel, you can you have for making it, you have to melt it, you have to weld it, do some kind. I mean, customizing is very difficult compared to steel. I mean, the easier here compared to steel. Maximum reuse. You can still reuse it quite a number of times. Easy to fix insert, right? We can easy to fix inserts like if it is a reinforced concrete, if it is sometimes reinforcement, sometimes the tube, like the piling itself is inserted into the concrete, is still handleable if it is a timber. Adjustable, right? Adjustable, and then fix it back to the original shape if it is a timber. Disadvantages. There are quite a number of disadvantages. Can't be used for long, right? Very long time duration. Have limited reuse. Can only use 5 or 6 times because of the property of the material. A timber can be used only 5 or 6 times. If it is coming for 20 times, a good number. 6 times. It's a rough number. Rough number. There is no. We cannot expect a very optimistic number. At least reusable, property of reusable can save money, right? If the timber is dry, it will absorb moisture from wet concrete, which could weaken the resultant concrete member. That's why I said tend to absorb the moisture from the concrete which is poured inside. By that, it can lose the concrete, the element can lose its own strength. So this is the problem. Timber with high moisture content, more than 20% of moisture content, wet concrete will shrink and cup, leading to open joints. Another problem is high moisture content, like the green wood, raw wood, unprocessed wood can started shrinking, right? Unprocessed wood will, when it is sunny, it will start shrinking. When it shrinks, there will be a gap, right? There will be a gap between the layers of the wood, which has to be fixed, right, before you pour in concrete. Not enough strength as compared to steel formwork to carry large pressure. Yeah, it has a reasonable strength, not a very good strength to take care. So you cannot use for very heavy loads like high-rise buildings, multi-stories, right? You can use for residential buildings up to 2-3 floors, shop lots of 2 floors, 3 floors. High-rise building, you have to go for steel. Although it has some advantages of being affordable, being handleable, customizing is easier, you have to avoid for high-rise buildings due to its strength and other defects. Excessive shrinkage due to temperature changes. Yeah, it is reacting for temperatures, right? It is not stable for the diurnal time or the 2 different temperatures during one day. Leakage through the joints and apertures, the holes and apertures, chances of growing, chances of yielding more leakages later on. Easily, although you fix it, you identify, you fix it, good. If you don't, if you miss out in a very big formwork, it will grow, it will be growing and become a big joint or a failure of the formwork itself. easily damaged during fixing and dismantling of formwork. Yeah. Wood, the 10 to mean wood is not so strong. At times, if you if you pile it too many, chances of breaking. If you want to speed up the process, you speed up the construction, you pile it to very high height, bring it to the side, chances of breaking, right? Then the pattern of grain, knots, bad flaws will leave imprint to the face of the concrete. So if unnoticed, if these type of breakages, damages unnoticed, yeah, there is a chances of uh, breaking. I mean, you won't get the smooth surface of the final concrete member. So these are all the defects, mainly on the leakages, absorbing moisture content, too much drying also is a type of failure. And then temperature changes, it cannot withstand temperature changes. And then damages cannot be identified and fixed in the beginning itself. All these problems are due to timber. Have to choose for shorter duration or smaller construction, medium construction, not for very high projects or huge projects like these tunnels and pier, year-long projects. Warping, swelling, and shrinkages. You see the pictorial view of timber failure I have shown here. It is warping, bending. Warping is kind of a bending. It will bend, tend to bend, swell, thicken. It tend to shrink like this, shrink, try to shrink, or swell, or bend. All these types due to temperature change, moisture content change, and then climate change, right? And then when it mixes with there is a small hole, honeycomb, it will start building other types of failures or growing in action. By that it will spoil the whole member itself. Okay. Next is the metal formwork. Similar to this, you have metal formwork. We have time, right? We have time. Can we see one video before I go into metal formwork? It's an interesting one. One moment. Just 3 minutes only. It's not a good idea. I keep on talking. You should also appreciate how the technology has grown up. When I put the video, just 3 minutes video.
Doka South Africa introduces the globally renowned Doka Deck 30 panel floor formwork.
Okay, the Doka Deck 30 system we've brought into South Africa because we see the need for a modular lightweight system. There's not many components. We've kept them down to a minimum, which obviously makes life easier for labor. It's simple to erect because there are such few components, and it's easy to erect because they're so light.
The routine is simplicity itself. Fetch the Doka Deck 30 panel, engage one end, swing it up into position and prop with floor prop. One system with only 3 basic components: panels, heads, and props.
There's always training required in any system, doesn't matter how simple it is, because you have to concentrate on the safety aspect as well. But generally, because it's almost, it comes in kit form and it's just components that click together, if you like, and you don't have to use a measuring tape or anything like that, it just makes it that much easier for unskilled people to use. There's always a certain amount of measurement. You have to have a starting point, and you're working off a drawing. But the thing is, because we're using fairly large panels, you're putting up quite a lot of formwork in one hit, if you like. It's easy for 2 people to pick up even the largest panel, which measures 3 square meters in area. So you can appreciate that 3 square meters at a time is a big saving in work output. Well, one of the safety features we have is that the large panel, which is sitting on 2 galvanized steel props, there's an anti-dropout device that's built in, so they cannot. The panel cannot drop down on its own. It has to be lifted up and then moved away from the props, which ensures that there's not that danger of something falling on anything.
The Docker Deck 30 is geared towards the rough terrain of Africa, and construction companies will be surprised at its efficiency and its cost effectiveness.
At first glance, the system looks as though it might be too heavy, but it's not. The second thing is there is a pricing factor in it, and we don't claim to be the cheapest in town. But what we do claim is that if you use the system, you will become one of the cheapest in town because of the savings in labor and in maintenance. I keep coming back to the stock phrases from Docker, which is safe, fast, and efficient. You'll work safely, you'll be extremely fast, and because you're efficient, you should make money.
So just now you saw one composite member. It was using steel and as well as PVC, a composite member of formwork. I will continue with the metal next class. Shall we go for quizzes now? Are you ready?
Yes.
Yes.
Okay.
Kun Jae-won can't wait for it. He want to be number one.
One moment, I open the website for you. This is good in spirit. I appreciate. From work. Started. Very good question. I got to think and answer. There may be a few questions from metals. Let's try, because I don't want to drag it longer. I have to finish 3 more quizzes. Okay. Play live. Your classic mode. Continue. Okay. I share the slide so that you can copy your. This is the website and code. Let's start answering. Sorry, I had some.
Miss,
Yes.
hello, Miss.
Yes.
Can you share the link?
Yeah, I did. You check in your meeting chat. I put in meeting chat. Joinmyquiz.com and the code is 838109. Four people missing today. What happened? I post assignment by this weekend. You're supposed to use 2 weeks time. I'll give instruction, don't worry. $90 people join. Good. We are on good timekeeping. Can you see the code?
Yes.
10 more people, then I start. You're 110 today. 110. 10 more people. Please join on so that everyone, you don't miss it.
So Miss, our class is on Monday and Wednesday.
Yes, Monday and Wednesday, 5 to 6:30 p.m. I will go to the venue next class onwards. I will go to the class venue in the campus. We will have class there. Also, I connect by online. Dual mode class. Shall we start? 5 more people. Are you trying? Shall we start?
Yes, teacher.
Okay, good. One point on Des Victor. Ayong Win. Nadia Wen. Competition. Marwan. Cynthia. Nadia. Sigma. Nain. Yeah. Des Victor. Nursery. Yeah. Oh.
Teacher, can we leave now?
Yeah, once finished, you can leave. Next class. Bye. I think you have done. Which one you put more? Please. 102 have completed.
Miss, can I leave?
Yes, you can leave. You have completed, you can leave. You have completed, you can leave. If there is something to leave. Bye. Shall I stop here? You want to play? Who did you play? Khalid Mohammed. Yashwin the cow, pick it up. You are at the first. Keep up the position. Mohammed Mudi, Tanziha, Yashwin the cow, Boraya, Kaunka, Kanjovin, Kunjan. Okay, I stop here. Don't repeat. Okay? Good. See you next class. Bye bye. I want to pick the stickers. Okay.
Miss.
Bye bye. Any question?
Yes, I have a question.
Please.
Miss, yes, in this presentation, I don't see my topic beside my name.
You can edit it.
Oh, okay.
I
will edit it.
Yeah.
In schedule, there is the wrong topic. And
Same here, Miss.
You can edit it. You can edit it under presentation. Go to the assessment channel. Under the presentation title, you can edit it.
Miss,
So
we already edited it. We already
Yes,
edited it
in presentation schedule.
in the schedule.
We
Yeah,
cannot. We can also type
yeah,
it.
presentation
we have
schedule.
promised. Okay.
No, presentation schedule. I will amend it because the time get changed. Otherwise, do not worry about that. Just correct in the presentation title only. Later, I will copy to presentation schedule and post it once again towards the end of the week or before the presentation. Just 2 days before the presentation. Don't worry about the title.
Okay, Miss. Thanks.
Stick to
Okay,
the
Miss.
timing.
Thank you, Miss.
Yeah, we should not keep changing the time. That's why I didn't touch anything. Follow the timing given. Title can be changed or put in your slide correctly. That's it.
Okay. Okay, Miss. Thank you, Miss.
You're welcome. Bye bye.
Bye bye.